Hello everyone, welcome back to like day 100 of Recursion. I got a spicy one again for you today. We are doing fractals, specifically fractal trees. So these are fractals, right? These are like images made usually with recursion. We've been learning that recursion is an alternative to iteration. So in theory, you could do these with iteration. They're almost always done recursively. Specifically, what we're going to be making are fractal trees, things that look like this. Ours won't look as fancy as this, but you know we got a little something for this guy, maybe. Let's get started. This is more than likely a two-part little series, and it's going to involve a lot of JavaFX. I am in IntelliJ, and I'm making a new project. We're going to go next. Next, I'm calling this bad boy Fractal Trees. Okay, we're going to take it nice and easy. So I'm going to expand my project folder, right click on the SRC, let's do a new Java class. Driver, fractal trees, doesn't matter. Fractal trees. Really is fractal tree, singular, unless you get fancy with it. Okay. Again, we're going to be using JavaFX. JavaFX is kind of a newer way to do graphics in Java. Traditionally, we've had some stuff called AWT and something called Swing. AWT is more for like graphics. Swing was more for like GUIs, and sometimes you use those in combination. The JavaFX has kind of replaced both of those as like the go-to in terms of doing graphics and GUIs and stuff. And particularly, we don't teach it a lot because there's not a lot to teach. So like I could basically show you demos, but there's not like a lot of things to learn, right? Like with loops, it's very much so this is a concept. You got to learn how it works in order to like apply it. But with things like graphics and GUIs, it's just like here's how you do this. Here's how you do this. It's not really teachable moments. And then more so, you could just really get lost in it, right? You could spend, you're like, okay, let's change the color of the background. And then you realize like 20 minutes later, you've just been cycling through colors. And so it could just really eat up some time. So between those two things, we don't really dive too much deep into graphics. Even if you go deep into computer science, you don't dive into graphics, especially because probably the main way you're going to end up using Java in the real world, if you proceed to do it, is actually programming Android apps, which is going to use something completely different. So here we got fractal trees, and very importantly, we're going to extend application. Notice that this is coming from javafx.application. Whenever I actually extend this, it's going to auto import for us. So we are extending application. Also notice this is mad at me. Why? Let's scroll over this bad boy. At some point, can you ever have to save information using Java? More than the easiest thing to do is actually save stuff to a text file. I would look at maybe like write buffer or something like that. All right, so this is mad at me largely because we got some type of method that is abstract and it needs to be implemented. So it's showing me I can Alt-Shift-Enter to implement. Alt-Shift-Enter. Something. I don't know. I'm going to right-click in free space and tell it to, wait, I guess we can Control-I. Yeah, Control-I. So I got this method. It is abstract, right? We extended application. This is an abstract method. We need to give it a body. So I'm going to tell it to override this, and IntelliJ throws this in for me. This is the only thing that is abstract. This is the only thing that we have to override, right, with our concrete class. Let's see where we're going from there. We're going to come back to this stage, and that's where kind of like this is going to be like kind of the main method for our application. That being said, we're still going to have a main method. It's going to trigger a launch. Right, so I got my main method. We're going to tell it to launch, and then we're going to pass in args. We're just going to do a bunch of hand waving today, be like, don't worry about that. Right, when our main method triggers, whenever we go to run this, it's actually going to start an application and kind of not go through the main method anymore after that. Okay, so this is realities. This is kind of like our main method, and we have a stage coming in. I wouldn't worry about that. I wouldn't worry about this exception. Some stuff that we can worry about is the first thing that's going to happen is we'll take our stage and set the title. What this is going to do is, so ultimately this is going to launch in a window, which we're actually going to do very, very soon. And the title here is going to be what it says. Let's see if I got something like nearby, right? Like if I was to run like Notepad, right here it says Untitled Notepad. That's the title. That's the title that we're setting on our window. And let's call that Fractal Trees. What does throws exception mean? So these are like runtime errors. So you've seen stuff like index out of bounds exception or array index out of bounds exception, stack overflow. Exceptions are errors that happen at runtime. Now, they actually get kind of coded in as objects in Java. And so you can actually make your own custom exception. Right? Those exceptions that you commonly see, things like stack overflow, things like index out of bounds, they were written, they're a part of Java, and so it's a way to get very specific about the error message that's happening. Now in this case, this is just the most generic it could possibly be. It could just be, hey, something went wrong. Don't worry about it. So I've set my title. Let's basically give like some width to this, some width and length. And the length and the width, I'm actually going to refer to like at several different points. So one thing I actually kind of recommend here is let's make some instance variables. So they're actually going to be private final. So we'll refer to them as constants. And because they're final, there's the constant. It can't be changed. The convention we actually use is to capitalize these variables. So I'm going to have a double for my width and height. Now, if I was to try to just stop right there, right, I have private final double width. This is mad at me. If we actually scroll over, it'll tell us it may not have been initialized. When you have a final variable, what final does is it means that this variable, once it is set, it cannot change. Okay? Well, right now, it's a little bit mad at us because if we don't give it a value, it's going to try to assume a default value. The problem with assuming a default value of 0.0 is this is final. And because of that, it's going to take on the value of 0.0 and then it literally can't change from there. And so with a final variable, you have to give it a value right away. What I'm actually going to do here is this is the width of our application, of our window. And let's just start out with something like 400. Okay, notice this is happy with me now. We're making a private final variable. It is in the body of the class, which means I can access it in any of the methods. Let's go ahead and tack on one for our height. And by convention, these final variables, they're capitalized. The reason being, if we see them, like in context, it's all capital letters, you know without having to go and dig and find the declaration that this variable is final. Let's see what we're going to do with that. I'm trying to do like the bare minimum to get something on our screen. I'm back down in my start method again. And what I have here is scene. Scene, I'm going to need a group, aren't I? Pause on that. Up here with our variables, we're going to throw in something called a group. I did not make this one final because we're actually going to be making edits to it throughout. And the reason I'm making it as variable is I'm going to have several methods that want to reference it later on. Now I need to import this. I can hover over it, hit Alt-Enter, and this is coming out of JavaFx. All right, so I have these three variables. I'm not going to add any more. These are constants because they are final. This one, this group, this can change. Okay. I am down. Now I'm down in my start method. I want to take that group variable and actually initialize it. Now I can do my scene. Scene is a new scene. I need to import this. Again, I can hover over it, hit Alt-Enter. Again, I'm trying to do like the bare minimum to get like something on our screen. So I'm going to pass in the group. I'm going to pass in a width, a height, and then the last thing it wants is a background color. We'll come back to this group. The width is obviously the 400. This is pixels. This height is 400, again, pixels. So this is a 400 by 400 window or scene. And the last thing I need to give it is a background color, which I'm going to do gray. So color, also coming out of JavaFx. Notice that I'm doing color dot gray. What this is that this is a static final variable, right? So essentially this color class has established a bunch of pre-made colors and we can refer to them. I know it's static because I'm referring to the class. I know it's final because this is capitalized, right? And it's not a method. That's how I know it's a variable, because there's no parentheses. And so I'm pulling out a pre-made color from the color class. And that's going to be my background color. Right, we're going to do stage.setScene. Right, this is, we just built this scene here. We're going to pass it into our stage. And the last thing I'm going to do is tell it to show the stage. And I believe this is something that we can kind of run and execute. All we're doing is setting the title. This is just like some setup stuff, but we basically set the width and the height. It's a 400 by 400 window, and the background of it should be gray. I'm going to right click in free space and tell it to run this. And we're crossing some fingers here. I'm hoping we get something out of this. There we go. Here's my little 400 by 400 window, our little canvas or scene that we're going to be actually coding in. And notice that it's called Fractal Trees because I've set the title here. It's 400 by 400 because that is our width and our height. And our background color is indeed gray. Is there not some big JavaFX thing we can import with all this stuff? Yeah, you could, in theory, just import everything out of JavaFX. Import JavaFX.asterisk or something. We can definitely probably do. What does it like about this? You can maybe do scene.asterisk. Right? You could do this little asterisk to kind of import like a whole package, right? These are basically subfolders. There's a folder called JavaFX, and there's a subfolder called scene, and I'm saying let's import everything from there. This is not good convention. The reason being is if I come in here and look at the imports, I know very specifically, just by looking at the imports, the things that you are using. Now, there's a lot more than just these things coming out of scene. If I were to see only this, right, I could basically get rid of all these. Ignore this for now. I can basically get rid of all these. This is just not good convention because I don't know exactly what you're using coming out of scene. And so I tend to tell people not to do this. This is, I mean, besides, all this stuff is like auto-imported for us with IntelliJ anyway. I don't know why you would want to try to add more manual steps to this. All right, so we got our window. It is 400 by 400 with a black background, and we've titled it. Let's kind of do a first little drawing on it. So what we can do is you can draw like shapes, like rectangles, lines, etc. And our fractal tree, right, keep in mind, we're going to be ultimately making one of these bad boys. It's a bunch of lines. So why don't I show you how to do like a single line. Let's make a line. I really wish you would auto import that. This line is coming out of JavaFX scene.shape. It's a new line. Okay, I'm going to pull up an API. Let's look at basically how we can make lines. So I'm going to do line API JavaFx. If I click on that bad boy, right, we got all this stuff, blah, 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 constructor summary. You can make a line, which is basically nothing in it, right? We could just do a no args line. Or here's what we need to do a line. You basically need 2 points. You need a start point, XY, and you need an end point, XY. And that's how you can make a line. Okay, these are basically pixels. So why don't we just throw in some numbers here? Like, right, if I did like 50, 50, and 100, 100. Right, I'm saying let's start the line at point 50, 50, and let's end the line at point 100, 100. Let's run this bad boy and see what that looks like. Just kidding, we actually got to add it. So we want to take that line and add it to our group. Don't ask, because I don't know, but we're going to take our group, get children, add all this line. This is one of those things I just got to wave my hands. This is how it works. There's not really learning here. It's just this is how it works. So I'm going to add that line to the group. The group gets added to the scene, and then we add the scene to our stage. We ultimately show that. I don't know why there's all these things in here. This is what we do. I'm tell it to run that bad boy, and there I have a line. Right? It starts at 50, 50 and goes to 100. So something super important of note. This is just a 2D array. It's a 2D array of pixels. Now, very importantly, 0, 0 is not down here in the bottom left-hand corner. 0, 0 is up here in the top left-hand corner. So our x-axis is positive going this way, and our y-axis is positive going this way. That's a little funky from what you're used to from geometry, but it does make sense, right? As in terms of how we read in English, we're going to actually start from the upper left-hand corner and move right. So that's it's a little weird to some people first starting out, but our 0, 0, our origin is actually in the upper left-hand corner. So this point right here where our line begins, this is 50, 50. We're 50 pixels X, sorry, we're 50 pixels X, and we're 50 pixels Y down. Now that means this is 100, 100. Okay. So, one thing I would like to show you is that how to change the color. Like our line is basically a black line. It's going to default to black. We can take the line and we can do something called set stroke. Right? Take a look. Set stroke takes in a paint value. We're going to do color dot white. So this line object that I created that goes from 50, 50 to 100, 100, we're going to take it, we're going to set the stroke, that is effectively the line color, to white. If I run this bad boy again, same thing, but instead of being black, the default, it is white. Now, you can play with this. I don't recommend it, and this is why we don't kind of teach these things, but if you do color dot, you can like go through and see all of the possible colors. There's a ton of pre-mades. You could also set the color by doing some type of RGB value, for instance. We talked about red, green, and blue. So for instance, like 0, 0, 0 is saying 0 red, 0 green, 0 blue. And IntelliJ is pretty baller. It actually shows us over here off to the side what that is. This is just black, right? And these numbers each range from 0 to 255. Full on 255 would give me white. And of course we could do anything in between. If I was to do 0 green, that's full on red, full on blue. That gives me this purple. It looks kind of magenta to me. So there's lots of things that you can do there with those colors. You can really get deep in it, but the fact that you can input numbers makes things interesting. We'll come back to that idea. Okay. I see some people having issues in chat, and yeah, I'm hoping my chat will help them figure that out. Not going to lie. So let's take a look at this fractal tree. What it is a line. This one looks a little closer to what we're doing. We have this line here, and then all it is 2 lines coming off, right? And then if I follow that one line, there's 2 lines coming off that. We could call this a branch. A line that then has 2 more lines coming off of it is our branch. And that is basically going to be our the method that's doing like all of the work. Okay, so I am back here in my Fractal Trees. We're going to write this method that draws our branches. Ready? Private void branch. Now branch is going to take in a point 2D. I'll come back to that a little bit more later. Well, I can talk about it now. We need 2 coordinates, right? An X and a Y in order to designate the start point. We need essentially an X and a Y to designate the stop point. We could just take those 2 numbers and wrap them in a single object. This is just like location with our battleship, right? Instead of having multiple parameters, I could just tuck them into a single object, and we're calling that that already exists. It's called a point 2D. This is going to be my origin. Origin. Okay. In order for me to make a branch, I need to know where is it starting. I'm also going to take in a double, which is rotation, because effectively what we're going to do is draw the line and then rotate it. Draw the line and then rotate it. And the last thing I want is a length, which I'm just calling len. Let's JavaDoc this, because that's a lot of stuff. Okay. Origin is basically the X and Y on where to start drawing. Rotation, I think that kind of makes sense. It is measured in degrees, I believe. I need to double check that. And the length is how long the line should be. And this is measured in pixels. Ultimately, the reason why we're taking in a length is so that we can actually make the branches smaller and smaller and smaller as we go. Right? This guy is huge starting out, because this is ultimately one branch. I know it's a tree trunk here in practice, but it's a branch. And we have one line with 2 lines coming off of it. And these branches get smaller and smaller and smaller. Okay? What I want to do is draw a line. Anytime we call branch, we want to draw a line, and then we want to, from that, make 2 more branches. That's where the recursion is going to kick in. So I'm going to come up here. I'm going to grab these 3 lines, and I'm going to cut them out, because this is what's going to be happening inside of our method. So I'm going to Control X to cut that. And I'm going to paste them down there. The point 2D is coming out of geometry, right? JavaFx geometry point 2D. Okay, so whenever we go to make a branch, we're going to draw a line. Instead of using this X and Y, right? This is where I'm wanting to start from. We're going to basically pull out this origin. Right? So where I want to start is actually origin dot get X. And origin dot get Y. Now, the ending is going to be difficult. We're going to have to do some calculations on that. But this will draw us our initial line. We're going to set it to white. We're going to add it to our child. Okay. So I'm back up in my start here, and we still need to get that initial line drawn. We need to draw our tree trunk here. So what I want to do is call branch. Branch is going to take in some stuff. I need a point2D, which I can actually just make here on the spot. New point2D. But I need some help. Right? This takes in an X and a Y. I want my tree trunk here just like this, right? And the very bottom center. Help me out with that. And I don't want raw values. I want it in terms of my width and my height. The reason I want it in terms of width and height is so that it'll scale with this window, right? Good. Our X value here is width divided by 2. And then for height, right? If we are starting, if this point in the upper left-hand corner, this is 0, 0, right? X is going positive this way, Y is going positive this way. In order to get down here, my Y value, it's literally height. Right? So that's our point. This is our point of origin. Halfway over in terms of our width, and then all the way down in terms of our height. Okay, I need a rotation. Let's just do 0 for now and see what that does. And the last thing we need is how long do you want it to be? Let's say like 100 pixels. All right, so this is going to call my branch, and we're going to notice that we're kind of ignoring the rotation and length currently. There's some math that's going to have to come in on that, which we'll take care of tomorrow. But what it's going to do is set an origin point and then try to draw all the way from that origin to 100, 100. Now it's going to be a little crooked, and that's okay. Let's try this out. This rotation and this length are basically being ignored. Okay, so here's my origin point down here at the bottom. We're going half of the width, but all of the height in order to get there. It's my fat head covering this up. Oh no, we're good. I'm not doing anything with the rotation, and we're just going from that origin point to 100, 100. And I'm not doing anything with the length. Okay, so trying to think, what do I want to do? What do I want to do? I think we may just pause it there, guys. I don't want these videos to get too long. And what we're going to be coming in with is some math, pretty heavy, to figure out how do you, right? Because we have to take a line. The way that we make a line is that we have an X and a Y starting location, and we have an X and a Y ending location. But I need to basically take a single point, a rotation, and a length, how long I want it to be. Really, this length is more important than rotation, and draw a line. I got to figure out what the X and Y endpoint is based off that. So we're actually going to pause there. I'm going to pick it up tomorrow. I'm glad we got something on the screen, but we'll pick it up tomorrow with part 2 of drawing fractal trees.